So I'm Sebastian Rosset, principal engineer. I have been in the UCS engineering for about 8 years. And in this session, I will talk about, it's a continuation of the previous session about UCS Starship. I will go in more details about security and monitoring. So one personal story, so several years ago, I was the chief security architect for a DoD program. So I spent a lot of time thinking about security. And one thing I learned a long time ago is that when it comes to security, you really have to have a lot of humility. And you need to have a really healthy dose of paranoia. You're never done, you're never happy with the state because there's always more that you can do. And there's always more threats. Now when it comes to Starship, when I started that, we was a very small team. And it basically started, okay, the first thing is we have to think about is security. We can build great features, so we can do all sorts of cool stuff, but if it's not secure, if we don't build with security in mind from day one, this is clearly not going to work. And then with that, there's a lot of issues with a lot of new threats. It's very dynamic. There's the typical technical aspects like zero-day attacks and the management hell of security patches and so forth. But there's also a growing complexity. Today there's easily over 500 companies who work in the security space. It's heavily fragmented. They each work on different aspects of security. And then when we do Starship, there's all these layers from the architecture, from threat modeling, but also to operation. Operation is, I would say, probably one of the biggest problems and one of the reasons why we have so many security breaches. It's because there's a lack of training. All it takes is a single employee who hasn't been trained and doesn't really know what they have to do with regard to security. Or it could be that there's a lack of procedures, even to the point that travel policies can impact. If you have too many people from the DevOps team traveling at the same time and then something happens, well, you have a problem. So you need to think about all these issues when you design the product. So the first thing that we embarked when I started on this project is let's get the best people in the security area. And fortunately at Cisco we have a great team. We have great teams both on the product side but also on the InfoSec side to go from zero, where you have something that you're confident you can deploy in the cloud, and addressing really a lot of aspects. There were 123 requirements that each of them had a lot of details, could take weeks to implement, and then also it has to go on a continuous basis. So it's not like we're done after 6 months of engagement with full-time employees. It has to keep going every single day, every single month. So we covered things like threat modeling, security architecture, how we are going to train engineers who, for example, they're experts in UI, but they may not be experts in security, or they're experts in database, but they are not experts in security. And we also need a core team who have specialty in security. And then, of course, the technical aspects, design or implementation and operations. So this is some of the elements that we covered for security. So to me, this is not just about the technical aspects. It covers things like personally identifiable information, and the requirements change depending on the regional aspects. For example, if you're in Germany, you can't display usernames. You have to show a surrogate keys in the product because otherwise that would be illegal, and because of the employee surveillance laws. Then you have things like privacy, data anonymization, and data masking. If I'm if I'm, let's say, a small business, and I don't want to overgeneralize, but you may want to push more of the responsibility to Cisco because you just don't have the employees to take care of operationally. And you're going to trust Cisco to do the right thing. Now, if you're, let's say, a financial institution, then actually you have regulations that where you need to have control, so that we are putting policies in place where the customer can define what they want to share, what they don't want to share. And also internally, we have lots of different roles. So we have the engineers, we have data guardians, we have the TAC team. And if I'm a TAC user and I'm actually working on a case for a customer, then I actually want to be able to access sensitive data because the customer is authorizing me to. But that doesn't mean that all of a sudden I should have access to the entire database across all accounts. So there are all these things that have to be put in place. Export control, laws, regulations. And there's also, it touches on SLAs. So from an architecture, we have spent a significant amount of resources doing things like static code analysis, security hardening at the multiple layers, so OS, Docker, containers, and the application. And then from the operation perspective, we have done penetration testing, and we are doing periodic security drills. We just completed one a couple of days ago. And every time it exposes a new problem, we take this as a feedback loop to enhance our processes. If you have 98, let's say 90 engineers who work on the product, there's always going to be someone who's on PTO, and if there's a security incident, then we need to have procedures to handle all these cases. And security training, every engineer who is working on Starship had to go to do specific training. So just to take an example of what we're doing, so we have put a secure Bootstrap layer that is really the root of trust for all of the secrets in Starship and all of the sensitive data. So nobody, like I'm the architect, I know a lot of how things work, but I don't have the keys to the kingdom. We actually start with split keys. So we have cryptographic keys that are split among multiple DevOps users. And nobody has full access to the entire private keys. So I have part of that private key, and there are other engineers who have part of that private keys, and they all have to agree on the operation to actually apply those things, whatever operations that we need to do. Those keys are encrypted with unique PGP keys. So whenever we have an operation, it actually involves a set of people, so you cannot have a single employee, which typically it's not going to be a malicious intent, but it could be even so accidental that somebody is making a mistake. So that actually helps to have multiple people in the same room. And then this is used to establish the root of trust, and then from there we have secrets for the databases, for applications. So nobody knows the passwords for our MySQL database, for example. I don't know it. Nobody has access to it. It's completely managed by Vault. So which is actually a good way to make sure that you're not copy-pasting those secrets somewhere and then accidentally you get a virus and then it's out in the wild. So just quickly, so we have a dashboard. This is for our internal use, but we have spent a lot of time thinking about how we're going to monitor the system from a performance perspective, from an availability perspective, and from a security perspective. So we have dashboards, and we literally collect thousands of metrics. We have some high-level metrics, like whether the site is up. Also things like percentile latency of the APIs, we measure that. And also lower-level metrics that would measure specific transaction rate at the database, the active users, and so forth. So, and we have set alarms. So basically, we can go through that, and look at trends, and based on that, we can do predictive analytics on when we need to scale up the system or when there's some anomalous behavior. There's a lot of metrics that we can access. So you had a question earlier about the user access control. So we have built an RBAC system. Right now in Tech Preview, when you create an account, you need to have a CCO user ID. And the moment that you want to do active management, you need to prove that you actually own the equipment. And so this is done by actually going to something like UCS Manager or the BMC or the HyperFlex HX Connect interface. And the device connector connects to the cloud. It will obtain a security token that keeps changing every 30 seconds, I think. And to access that information, first you need to actually log into that device with admin privileges. If you don't have admin privileges, you can't access that information. So that one is you have to prove that you actually manage this equipment. You cannot have somebody who is just walking by in the data center and then somehow registering that equipment and claiming that equipment. So there's a claim process that is in place to ensure that only administrators of that equipment can register it. Then within an account, we have an RBAC system in place with users, user groups, roles. So when you log in, you will be able to select the role that you want to have for that particular session. And roles have a set of privilege sets associated with them, privileges which are very fine-grained. So there is a set of predefined roles, but you will be also to be able to add your own roles at the API level, specify what is doable, what is not doable, including whether or not you want to expose the cross-launch to UCSM or not. And one thing that we're also working on is to add the ability to connect to your own Active Directory. So there are a few ways that can be done with SAML and MFA. So to have an additional layer of security to prove that not only you have the credentials and some additional token.
Yeah, those are basically my two questions: is SAML integration, and yeah, if a company doesn't have SAML already, if you can do MFA with any dozen MFA providers. So.
Right.
Cool. Does the administrator have the ability to modify the bundle of trusted certificates on the UCS hardware?
So you mean the trusted certificates?
If I have to crack the SSL used by.
Okay, so so there's a set of certificates which are used to connect from the device connector to Starship.
Yep.
And the end user doesn't change those certificates. We don't want to have actually some attacker making a change and then all of a sudden you go to bad.com or some wrong site. But if you have let's say you want to have a web proxy, you have the ability to configure a web proxy which enables you to go through some web proxy appliance to then go to Starship.
Okay, so I can use a proxy, but I can't man in the middle of my own connections.
Right. So now shifting to monitoring, and monitoring is all tightly coupled to security, but I want to focus on 3 use cases. The fact that we are deploying Starship, that we have a huge opportunity for analytics because there's so much data. So 3 use cases here. One is configuration analysis. It's basically about making recommendations for the customer to achieve specific goals. So for example, a customer may want to say, okay, this period of time, my goal is to minimize power, or I have some power budget. But it could be something around CPU performance, any number of goals. Now, if based on our own internal testing with the QA, with the certification teams, we can provide recommendations on what is the best configuration to achieve a specific goal. And then there's also the community aspect of it. If by analyzing the data anonymously, we can identify patterns of, okay, this set of systems, it's the best configuration to achieve these goals. This other cluster that is best to achieve another set of goals. Then another area is failure detection. So we could run analytics for, let's say, 1 million DIMMs or 5 million DIMMs over 12 months and get all these ECC errors, collect temperature, collect power usage variations, and then find some correlation. So DIMM is just an example, but it could be applied to PSUs, to disks, or any parts of the system, and even firmware. And then based on those patterns, identify what are the conditions under which there might be a failure, or how you can fine-tune the system to avoid those issues in the first place. And then the other use case is proactive tech support. So if you have, same thing, a lot of data across lots of customers, one thing we can do is if there is in a particular corner case, there's a situation that leads to software failure or hardware failures, it's something that at scale we can identify quickly, and we can be a lot more proactive to help the customer prevent those issues. Like today, unfortunately, we post something on Cisco.com, and after that, it's really hard to control. I mean, you have fill notices, but we don't have a really good way to notify the customer and prevent those issues in the first place. So just a specific example, if you think about firmware upgrade. So if you, as a customer, you perform a software upgrade, you're going to have the typical events to download firmware, to update the firmware, to activate the firmware, and then a few minutes later, the system will reboot, and it is running with the new desired firmware version. Now, if you do this at scale, even for our internal consumption, we have thousands of servers, so we can. It's easy to do some analytics. And now, if you do this with the 100,000 servers, with 1 million servers, then it gets even better. But that's not it, right? Because just because the firmware has been updated doesn't mean that over the long term it's going to work great. So we want to be able to look at events that occur several minutes, several hours, days, months after that event, including things like reboots, process crashes, DIMM failures, unusual power usage patterns. And then based on that, assign something like a score factor for the reliability of that firmware, and do maybe identify specific cases under which there might be a failure. This is just an example, but of course I think it's easy to think that at scale you can do this across many other scenarios like DIMM failures, disk failure, and so forth. And so how do we do this? I guess another architecture slide. So you have the UCS servers that could be standalone or FI attached. HyperFlex, they have device connectors. And within the device connectors, there is telemetry data that is being sent to Starship. It can be streaming logs in near real time. It can be batch logs. That's something that we're going to expose to control. Like, for example, if you don't want to have anything being sent between 8 a.m. and 5 p.m. or whatever. And then in the back end, we have a log processing system that can look at the logs it's ingested in Spark for time series analysis and machine learning, send back to Kafka, and then push to other data sources like Elasticsearch, and then we can expose that to APIs or internally for data visualization. Then the engineering team, the TMEs, the escalation team can look at that and say, oh, okay, across the 10 last months, we've seen DIMM patterns, let's say between DDR3 versus DDR4, that under these particular conditions, there's a problem. And let's build a recommendation. And of course, the customer doesn't have to look at all these in details, but it ultimately results in a very simple recommendation to the end customer. That is it. Any questions?
What about security monitoring of the customer system?
So security monitoring, there are lots of layers. One aspect would be the security monitoring of firmware management. Let's say you're running UCS servers with HyperFlex. So you're running VMware ESXi 6.5 update 2, and then on top of that you have HyperFlex. So there's the basics of collecting all of the firmware versions, and then I had another slide previously where it connects to the tag database, our bug database, and then correlating that to PCert information. So instead of having to do that manually, it's going to be much simpler. We can identify, hey, you're running this particular version of the firmware. You know what? There's a security vulnerability with that firmware, and then we do a recommendation to upgrade to a newer version. That's an example. Now, I think there's at least, so I can see lots of opportunities to go beyond that. And security, there's so many things, like the firewalls. So we'll have to pick use cases. I don't think we're not going to claim that, hey, we're going to solve all of your security issues because it's such a large problem. But I think there's a lot of use cases that we can address to make the life of the customer much easier and spend less time identifying what are the problematic issues and then doing the upgrades.